Good afternoon. My name is Carlos Chick. I will be representing and explaining thermal system as best as possible. The thermal system that we will be viewing is a double heat exchanger. And here we have the problem we're looking into. Here we have a warm water with a flow rate of 5 SLPM enters the inner stainless steel pipe. The temperature entering is 50 Celsius and exits at 40 Celsius. The cool water at a flow rate of 4 SLPM enters the annular tube of the heat exchanger temperature of 20 Celsius and exits at 30 Celsius. As here we have a schematic drawn in SolidWorks with a showing our control volume, which is the heat exchanger double pipe itself. And here in the middle, as mentioned, where the warm fluid goes through from left to right, and the cold fluid as well from left to right goes through here, the annular part. And the reason we show, as we shown in the previous slide on the problem, we had this where the control volume is happening, is being circled, since the rest of the objects that were in purple are the sensors. So to show here, this is our control volume in the box. And we have our variables and assumptions. We as well mixed, no external work, no accumulation, since the volume wasn't stated in the problem that the volume will be changing. So we assume that it's a constant volume. As also mentioned in the problem, is a parallel flow, steady flow of water, constant mass flow rate, pressure, kinetic energy change in the fluid, negligible and incompressible fluid, non-turbulent, and a parallel fluid flow. So here our input, as mentioned from the problem, is the cold flow rate VC, in which we also indicate to be our manipulated variable, since by default it seems to be the only input flow rate. And then we have here the output is our exiting warm temperature of T warm exit. Here we have our mass balance equations. As we start with accumulation equals N minus out plus generate and reaction. So here we assume accumulation equals 0, since there seems to be assuming that there's a constant volume, since the problem doesn't state any change in volume. Also, we don't have a chemical reaction, so this is why our Rxn equals 0, which then also makes our generation equal to 0. So which then gives us equation 1.2 of 0 equals N minus out dm over dt equals m dot density minus the mass flow rate of density. And the reason since in the problem the values we are given is volume flow rate, we can relate mass flow rate with the density of the fluid, as we shown in this equation 1.2. And once we equal the inner mass flow rate minus the outer mass flow rate, we divide the density from both sides, which we obtain the following equation of 1.4. Mass flow rate out equals mass flow rate in. Here we have our energy balance equation, which is in here for our case of a thermal is the heat balance of a parallel flow. As we start with En equals E out, we also follow the same process of accumulation equals N minus out plus a chemical reaction plus a surrounding. Here we assume our surrounding, that we do have a surrounding, since the problem states there's no insulation. So here we change our values to the QW equals QC plus QS of equation 2.2. And since we have since energy balance, we use enthalpy for the use of our heat. So we have mass flow rate warm times enthalpy equals MCH, which is also mass flow rate times enthalpy of our cold plus mass flow rate of our surrounding times our enthalpy. This is here in 2.4, we have QW equals M dot WC P warm. TWI equal TWO, this is the warm side. The QC, which is for the code. The QS is for the surround. And with the H, it's can equal to the specific heat of our delta temperature for each of the warm, the cold, and the surround, as shown in equation 2.5. Equation 2.6, we eliminate the surround since as in our hand calculations, we absorb and assume that our surrounding is negligible, where we obtain just the warm mass flow rate of specific heat times the delta T, which equals our mass flow rate of the cold specific heat times our delta T. Although in this exam we were to present also a time domain, a block diagram, and a PNID, which will be in a later video. Thanks.